Hi, good morning. This is lesson 17 on squares and cubes. So let's go ahead and get started. Let's investigate perfect squares and perfect cubes. So 17.1 says perfect squares. The number 9 is a perfect square because we can create the area of 9 and we know that the sides are a 3 by 3. So now we need to name 4 other numbers that are also perfect squares and then 2 numbers that are not perfect squares. So if we want to make another square, we could do a 1 by 1. So 1 times 1 is 1. We could also do a 2 by 2, which is 4. 3 by 3 is 9. So a 4 by 4 is 16. 5 times 5 is 25. 6 times 6 is 36. We can keep going just because I want to make sure that everyone kind of is aware of these perfect squares that we have. 49 because 7 times 7. 64, 8 times 8. 81, 9 times 9, 100, 10 times 10, 121, 11 times 11, 144, 12 by 12. Okay. Some non-perfect squares. So non-perfect squares. Could be 20, 15. So any number that you can't multiply a whole number times itself to get the product. So here's a list all the way through 144. So number 2, a square has a side length of 7. What is its area? So if we draw a square, we know that 7, 7, 7, 7 goes on all the sides. Area is length times width or base times height. So 7 times 7, which gives me an area of 49. So 49 kilometers squared. The area of a square is 64 square centimeters. So now they're giving us the area. What is its side length? So what times itself gives you 64? So something times itself gives me 64. That would be 8 times 8. So 8 is my side length. So 8 centimeters. All right. 17.2, your teacher will be giving you 32 snap cubes. Use them to build the largest single cube that you can. Each small cube has an edge length of 1. So I'm going to go ahead and do this for you just for sake of time. What I was able to build was a 3 by 3 by 3. And 3 by 3 by 3 uses 27 cubes. And then I had 5 left over. So I actually was not able to use all of them because if I did add more, it would not make a cube. Because remember, a cube has to have all the same side lengths. So 3 by 3 by 3. So how many snap cubes did you use? We used 27. What is the edge length of the cube you built? 3. What is the area of each of the faces? So this area is a 3 by 3, so 9. What is the volume? Remember, volume is length times width times height. So length times width times height is 3 times 3 times 3, which gives me 27 units cubed. And this would give me units squared. Okay. All right. Next is 17.3. The number 27 is a perfect cube, which we just proved by building this cube here. So 27 makes a perfect cube, and now they're saying it here. And that's because we were able to do 3 times 3 times 3 to get 27. Now we're going to name 4 other numbers that are perfect cubes and 2 numbers that are not. So here's the cube that we built. Okay, so 3 times 3 times 3 was 27. So let's start with 1. So 1 times 1 times 1 is 1. So there's the first one. 2 times 2 times 2. That gives me 4. And then times 2 is 8. 3 times 3 times 3. We just did that. That's 27. Here, let's put some boxes around these. And then you have 4 times 4 times 4, which is 64. And then you have 5 times 5 times 5, which is 125. And that is 4 perfect cubes. Non-perfect cubes, really you can give any number as long as it's not a number that multiplies times itself. So if we did 50, 50 is not, 20 is not. Okay. Now what I want you to do is pause the video and go ahead and answer numbers 2, 3, and 4. All right, now that you've unpaused the video and you've tried these on your own, number 2 has a cube, is a cube with a side length of 4, so we know that that's 4 times 4 times 4, which gives me 64 centimeters cubed. Number 3, a cube has a side length of 10 inches, so what is its volume? So 10 times 10 times 10, which is 1,000 inches cubed. And then number 4, a cube length has a side of S. So if we keep doing the side times the side times the side, and side times the side times the side, we can actually come up with a quick formula that includes any side length. So S. So if I didn't know what this length was, I could call this S, S, and S. So S times S times S gives me the volume. And that's how you would write that with variables. All right, moving on. 17.4. We're going to make sure to include correct units of measure as part of each answer. So a square has a side length of 10 centimeters. Use an exponent to express its area. Area is length times width. So we're going to say 10 times 10, but we're going to write that with an exponent. When you see two numbers that are multiplying each other, what you can do is you can write the 10, and then because it's multiplying it twice, you can raise it to the second power. So let me give you a quick review. If we were doing addition, I'm going to put this down here. If we were doing addition, 10 plus 10 plus 10 plus 10, a quicker way to do this would be 10 times 4, because you have 4 tens. But if we did 10 times 10 times 10 times 10, well, you still have tens, but you can't do times 4 because that shows repeated addition. Repeated multiplication, the symbol for that is an exponent. So just look at the difference there. So when you're repeatedly adding, you multiply times how many times you add. When you repeatedly multiply, you raise it to how many times you did it in the exponent. So the exponent is that small number in that top corner. All right. The area of a square is 7 squared square unit or square inches. What is its side length? So we know that we're taking 7 and multiplying times itself. So we know that one of the sides is just 7. And I forgot to put the units for number 1, so please make sure you do that. The area of a square is 81 meters squared. So notice how there's not the 2 there. The 81 is the area. So what times what gets you 81? So what times what gets you 81? And I'm using x as a variable, not multiplication. So x times x is 81. So what number is that? 9. So 9 meters is my answer. All right, go ahead and here we'll do number 4, and then you can do number 5 and 6. A cube has an edge length of 5. Use an exponent to express its volume. So remember, a cube is side times side times side. So 5 times 5 times 5. So over here, we said that this, if you multiply it twice, it's to the second power. So if we're multiplying it 3 times, it's to the third power. So 5 cubed, and then inches cubed. The inches cubed just means, this just means volume. So cubed inches. All right, the volume of a cube is 6, and this is a 3. So 6 cubed centimeters cubed. What is its edge length? Go ahead and answer that one, and then answer number 6, and pause the video, and then I will give you the answer in just a minute. All right, so the answer should be the side length is 6. And then the last one, a cube has an edge length of S. What is an exponent to write for its volume? Well, S times S times S, which we did earlier, really can be written as S to the third power. So now you've been introduced to exponents. So we're going to skip the Are You Ready for More just for sake of time. And then you guys are going to make sure you read the lesson summary, because that's a great summary to read. And then you're going to start on the lesson 17 practice problems. If you'll pause the video, and then when you're done with your practice problems, you may unpause it, and then I will give you the answers. All right, thank you for pausing the video. So number 1, the volume would be 2 times 2 times 2, which gives you a volume of 8 centimeters cubed. Number 2, decide if each number on the list is a perfect square. All of the numbers except for B. So A, C, D, E. Oh, not E, sorry, because it says perfect square. Not E. F, G, H. And then write a sentence that explains your reasoning. Perfect squares can be found by multiplying a whole number by itself. So a perfect square can be found by multiplying, a whole number times itself. All right. So not B or E. So those are not perfect squares. Number 3, decide if each number on the list is a perfect cube. So all of the answers are correct except for B, D, and G. Oh, sorry. So 1 is yes, not 3. 8 is yes, not 4. 5 is yes. 64 is actually yes. 100 is no. 125 is yes. So a perfect cube can be found by multiplying a whole number times itself 3 times. So a perfect cube can be found by multiplying times itself 3 times. All right. There you go. Number 4, a square has a side length of 4 centimeters. What is its area? So you should get 16 centimeters squared. The area of a square is 49 meters squared. What is its side length? Well, 7 times 7 is 49. And a cube has an edge length of 3, so what is its volume? So 3 times 3 times 3, which is 27 inches cubed. Okay. Number 5, we're going to select all that apply. So A is correct. B is correct. And E is correct. So prism A and B are rectangular prisms. Prism A has a 3 by 2 by 1. So prism A is a 3 by 2 by 1. And B is a 1 by 1 by 6. So the volume would be 3 times 2 times 1. So volume would be 6. And this one would also be 6. They have the same number of faces. Rectangular prisms all have faces of 6. And the surface area of B is greater than the surface area of prism A. The surface area for this would be 6 on one side, 6 on the other, so that's 12, plus 2, that's 14, plus another 2, that's 16, plus 3, that's 19, plus 3 more, that's 22, so a surface area of 22. And this one would be a side of 1 and 1, which is 1, but you got 2 of them, so that's 2. But then you have 4 sides that are 6. So 6, that's 24, so 26. Okay. Number 6, what polyhedron can be assembled from this net? This is a triangular prism. What information would you need to find its surface area? Be specific and label the diagram as needed. So you're going to need to know if you've got, so we need to know, let's see, let's call this A. We'll need to know that. We'll need to know B. We'll need to know C. And we'll need to know D. And then because A matches here, you don't need to label that because this would match with that. So as long as we know that, then we know that to help find the triangle. All right. Well, actually, they're saying that these are not right triangles, so let me fix that really quick. So they're saying that we'll need to know this, so we'll say that that's E. So as long as we have that, then we know that we have that one. So I'm not going to label everything because we know that these are the same as these. This is the same as that. C is the same over here. D are the same all the way over here. And then E is the same on this side as well. Okay, so those are all the things that we would need. All right, then problem 7. Find the surface area of this triangular prism. All the measurements are in meters. So what you can do is this. We've got this triangle that has a base of 1.2 and a height of 0.8 because I'm using this height here to match this height here. So this is 0.8. So I would do 1.2 times 0.8, divide it by 2, okay, because base times height divided by 2 for a triangle, but I have 2 identical triangles, so then I can just multiply times 2. So really these 2's negate and you don't really need them. So it takes care of my 2 triangles. Then I have 3 rectangles. So those are my 2 triangles. And then I have a rectangle on the bottom, which is a 1.2 times 1.2, so really it's a square. And then I have a rectangle here, which is a 1 by 1.2. And then I have a rectangle back here, which is also a 1 by 1.2. So I can actually just double this one because I have 2 identical rectangles. And then I take my calculator and then I can go ahead and figure that out. So 1.2 times 0.8 gives me 0.96. Divide by 2, then times by 2, so I'd still get 0.96. 1.2 times 1.2, 1.44. And then 1.1 times 1.2 is 1.2, and 1.2 times 2 is 2.4. And then when I add all this together, 2.4 plus 1.44 plus 0.96 is 4.8 meters squared. So I like to break up my shapes into their individual, and then I also like to draw them to make sure that I got all the faces, and then I write them out, I give their products, and I add them all together for their total surface area. All right, that's it for this video. If you have any questions, you can ask me tomorrow in class on Thursday. All right, have a great morning.